Hi everyone, this is Zach Link with ShardSecure. I wanted to go over an attack. It's basically a multi-factor authentication bypass on Azure, and also touch on how microsharding your data can help protect you from this type of an attack. So here's my Azure console, and I have a storage account set up here. A pretty standard type of deployment here. If we look at encryption on here, I've got server-side encryption turned on. And if you look at containers, I have a single container in here that has no public access. So if we go into files, I've got two files here, and you'll see that they're both encrypted, right? Server-side encrypted here, and they're private. They have no public access. This bottom file is actually just a file with some fake PII data, you can tell by the name. And the top file is actually the exact same data, but it's been microsharded using the ShardSecure engine. And so we'll go into that a little bit later, what difference this can make for you. But kind of the attack that I'm looking at here would be some type of like phishing or spear phishing attack on one of your cloud admins or one of your developers that actually has cloud access. And the attack would look something like this. Obviously a spear phishing attack, they get an email. If we can get them to click on something, PDF, an Office doc, a link somewhere, then we can probably run some type of exploit. So in this case, I'm actually just using reverse shell here. So let's go back and find the victim machine here. Sorry, this is the attacker machine. And you'll see a session just opened up. So there's my session to the victim machine. And I'm going to go ahead and interact with that. And hopefully I can type. All right. So now I have a reverse shell on the victim's machine. So I'm going to run my script. And this is just a script I wrote to automate a lot of this. But basically, it's going to be looking for any sort of cached access tokens on the endpoint, on the victim's endpoint, and no tokens were found. All right. So let's go back to the victim's machine. Now, I have MFA turned on here, but you'll know, as you guys know, a lot of developers and admins and stuff like to do things command line as well as through the console. So that's what I tend to do. So in that case, what we're going to do is just go in like this through PowerShell, do an AZ login. This is kind of a clever thing Microsoft does. I actually like it from convenience factor. So even from a command line, it actually pops up with a browser and allows you to log in through there. And that, of course, means we can go through the whole MFA process. So we're going to do that. And I don't know why it asks me my phone number every time. But I should be getting a text here. Looks like I actually got a couple, so hopefully this is the right one. And it was. All right, so I went through the whole multi-factor authentication steps, and now I'm logged in PowerShell. So Microsoft does something not so great too, though, which is they actually take your access token and store it on the local machine in an unprotected folder in clear text. And so that could be made a lot more secure. But the idea is that you shouldn't have to, every time you run a script or a new command, that you don't want to have to go through the whole MFA process every time, or just really kind of be unworkable. So that being said, let's see what we can do now from the attacker side. Let me just go rerun that same script. Because honestly, if we can spearfish one of your developers or admins, they're probably in command line, in and out all day long. These access tokens are fairly long-lived, and so they're useful for a long time. And there, boom, we already found the access token. Again, clear text, unprotected folder. I don't need to elevate privileges or anything to get that. And I'm going to go ahead and list out those files that I showed you earlier from that container. So there are those 2 files. And then I'm going to exfiltrate that. So that process, so even on the victim side, if you were using VPN or restricting by IP address, the download is going from the victim's box, right? So even though there's no public access to that storage account and that container, it's getting downloaded directly to the victim's box. And then I'm exfiltrating that out through the reverse shell. So even a VPN or anything like that wouldn't even help you here. And then you'll notice I got a new folder right here on my desktop, which is loots. So let's go look what's in that. So we'll just list it out first. And there's those 2 files that I just exfiltrated. So let's look at the PII data one. And you'll see everything's in clear text. And even though it was encrypted inside Azure, I didn't have to get any encryption keys or decrypt it in any way because I was going in as the admin. That's what that access token allows me to do. And so Microsoft or Azure is going to just go ahead and decrypt that for me and give it back to me in plain text. So you really kind of have to wonder the value of server-side keys on server-side encryption on that. Since now I have the file in clear text. But let's look at what the microsharded data looks like. And there's that file. And you can see it looks like garbage, right? So the process of microsharding, what we did was we take the file and we compress it. We add different types of compression on it, and then we split that. And this is what we would call microshards. They're 4-byte chunks of data, and then we mix them all up. We also inject poison data into that, and that's how we store it on disk. So when you get here, there's absolutely no context around what all these microshards do, how they relate to each other, how you could rebuild that file again and get any meaningful data out of this. The other thing, which I thought was kind of interesting, is if we go back to the victim machine, I actually saved copies of them here. And one of the things is the microsharded file, if you open up a notepad, it actually shows up as Asian characters. It looks at the file and there's no header information about it. There's no extension on it. And when the file's open, the data is just, it looks like a random series of bytes. And so Notepad looks at that and decides that they are probably Unicode characters and translates them to some Asian language. So you can imagine if you did have a breach and an attacker got this information, it'd be incredibly hard for them to make heads or tails of the information. And even once they did figure out, what was going on, it would be nearly impossible for them to actually put that data together in any sort of meaningful way where they could actually extract any of it. We're essentially talking, it's junk data on disk. The only way to get this data back is to go back in through the ShardSecure engine, which is highly secure, and request that file. The ShardSecure engine will merge that back on the fly and recreate your file for you.